For the lesson today, I will just record myself doing some work, and I will talk about the work as I do it. I won't explain absolutely everything I'm doing, though. So this project is a new house. I'll put on the screen some images of the house. These are called elevations. These are images of the house that are taken as if, or drawn as if a person is standing in front of the house or on the sides of the house. So these are different views of the house. These are the garage doors. There are three of them. So there's three separate garage doors. To me means a luxury house. We can see it's got level of windows up here and another level down here. So it's a two-story house. We can also see here that the entrance to the house is at the upper floor. And then there's this grade level here that's sloping. So this is a multi-level, like it's a sloping site. You can see it generally slopes like that, with the house being cut into the hillside. Like this amount of soil would be cut out, and then sometimes would be built up over there. But in this case, the house itself will slope down like that. So this piece of the hill gets just cut out. Okay. Because this house is on a hill, it has what's called pile foundations. So it will have these concrete columns that go like this. Come on. Down into the soil to support it, and that prevents the house from sliding down the hill and taking part of the hill with it. There's the front view of the house. Notice that you can only see the top story from this angle, but if you look from the side, there's the front. Okay, but behind that is the lower part of the lot, and the lower floor of the house is the back view of the house. We can see the stairs will be used on the outside if people want to go from an upstairs balcony down to a downstairs balcony or down to grade level. There's another side view of the house. Entrance is over here. Back porch or back patio deck is out there. Some of my, here, let's look at this detail specification, detail call out right here. So what it's doing is it's cutting through one of the piles. The circle represents a pile, and it's going through a grade beam also. So I need a detail like that to go in my structural plans. And let's look at some of the details I've already put in the plans. Here's one that would show, this shows a pile, and it shows the grade beam, wood framing of the floor, and then the wall up above that. So let's see if that is the case that we were looking at on the plan, which was here. It's not quite the same, because on this, in this case, we have floor framing that's on both sides, wood framing that'll be on both sides of the wall. So what I'm going to do is take a screenshot of this area using the snipping tool. I'm going to put that screenshot, there it is, so you can see it. I'm going to move it off to one of my other monitors. You won't be able to see it, but it's there. Now I'm going to go back to this, to my pile detail, my typical wall and piles at grade beam. And I need to modify this detail to show the wall, show floor framing on both sides. First, I'm going to go to my typical details file and see if I've already drawn anything like this. Oops, company standards. Let's try concrete details. My mouse is frozen. I need to wait for a second while AutoCAD figures itself out. Okay, so here are some concrete details, just quickly looking. None of these look like pile. Here's a pile detail. Okay, It's really a post though, embedded in a pile, wood post. That's not what we're looking for. This is more post, blah, 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 blah. I see also some retaining wall details. I'll just keep those in mind, come back to those, but really I don't see the details I'm looking for here. Let's go to the wood details file. That's our roof detail. Let's see about piles. Nope. Piles, piles, piles. Nope, nope, nope. Thought I had more pile details than this. There's typical pile detail. There's another one. Here, we could probably use this. Let's grab that. So I'm copying and pasting that. Okay. We will plop that one right here. Right there. Okay, now let's bring my screenshot back. So we see joists on two sides of the wall. They're parallel to the wall. And there's a shear wall that runs right down the middle. Okay, so let's get rid of the hold down, because those only exist at the ends of a shear wall, and I'm concerned with the remainder of the length of the shear wall, not just the ends. So I delete this stuff that relates to the hold down. And then the question is, am I going to have a concrete stem wall between the two wood floors? Let's see, how should I do that? I think the answer is no, I don't need that, and that's an engineering decision. Okay, I'll just stipulate that. So 14-inch deep joists, so I need to go to my toolbox and grab the image of a 14-inch deep joist. TJI 210s is what we'll use, 14 inches tall. Okay, boom, there's that. And if I go look back at the plan view, you can see here 14-inch TJI 210. Okay, and then they are, whoops, come on. I move that up like that, and then I use snapping to grab that corner and bring it down to there. So now the joist is placed right below the floor sheathing. Get rid of this stuff, don't need that, goodbye. This can go away, and the joists are going to be 16 inches apart. So I'll draw a line here that is 16 inches long, and then I copy the joist over like that to that end of that line 16 inches away. So these are now 16 inches apart, and I want the floor sheathing to come over just like that. Alright, this can go away. This represents gypboard or drywall, we don't need that. Let's see, how thick is the wall? I want to make sure I draw the wall. So this is going to be, by the way, 3 on sheet S3.0. Right, so I can update this detail reference to say 3 on S3.0. How thick is this wall? It is, from the architectural drawings, 8 inches thick. Huh. That's not a standard wall thickness. Let me double check the architectural section to see if I'm missing something about this. Because this architect has drawn cross sections of the house in fairly large detail. So I don't want to go and reinvent the wheel and then have to ask the architect to go change something that he had already thought out pretty well. So I'm going to look for a section through the house that is showing this area. Here we go. These are section detail callouts. So Is there one that goes right through the thing I'm trying to draw? We could check this one maybe, 2 on A11. Here. So what I see here is retaining wall, 8-inch thick retaining wall, concrete retaining wall. So on the architect's plan, when I see this being 8 inches thick, it means to me that he's planning to have an 8-inch thick wall. So, okay, so my detailing then needs to reflect the presence of an 8-inch thick concrete wall. Waiting for AutoCAD to wake up. Okay. So let's go back to our detail, 3 on 3.0. So there's our grade beam, and we need an 8-inch thick wall. So that's got to be, let's do this. Explode that shape. Here we go. That's that. Just come on. I keep grabbing the concrete fill. Let's move that out of there. This goes away. Here goes. Okay, and then I use offset, the 08, like that. Okay. And then I'll use rectangle. I'll draw a little rectangle out here like this, and then I'll extend these break lines out to the rectangle, which I'm using as a drawing aid, and then I delete the rectangle. Also, I know from the building code that we have to have 18 inches clear to the bottom of joists. So I'll draw this another drawing guideline. I'll offset it 18 inches down, and that's how far down the soil has to be. And I'm not going to have my grade beam sticking out of the soil. So we move this down, down, down to there, 18 inches down. All right, and then let's grab this stuff and bring it up like this. Okay. All right, and now let's bring our concrete wall edges down like that. This can go away because I've actually drawn this. I don't need break lines. I'm actually drawing the accurate length. Break lines are just a way to clue in somebody looking at your drawing to say, hey, I'm skipping something here. Like spatially, I'm skipping drawing part of this object, but it does exist. But since I am actually drawing the entire concrete stem wall height, then I don't need to use break lines. I am actually showing the whole thing. Okay, also I want that to be centered. And I want that stem wall to be centered, so what I'm going to do is draw a line that goes across like this. I'm going to highlight the stem wall, highlight my line, and then the O snap, whoops. Let's try that again. Highlight my wall, highlight my drawing aid, and then O snap helps me grab onto the center of the drawing aid line, and then I can move it over to the center of the top of this rectangle down here. Okay, so where's the soil going to be? Let's try to snip that off. We don't need all that, so I'll use cut or trim to trim the soil shading, soil fill out of there. Let's extend this. This is the soil crosshatch. Remove this guide point, this drawing control point. Right, and then there we go. I draw like a gray line at the top of the soil. Right, pull that over like that. This represents the soil surface, 18 inches below the bottom of the joist. Same thing will happen on the other side, so I'll just use mirror. Right, there I've mirrored it over. We can put this concrete hatch back now. This, we don't need that. And then this, let's move this up. The floor sheathing. Remember I said there's floor framing on both sides of the wall, so I'll extend out to that drawing aid I just made, boom. Right, and then we'll copy some more joists. I'm going to use the previously existing joist spacing to help me copy over, right? Those are all 16-inch like that. And then there won't be a joist right in the middle of the concrete wall. What happened there? Let's extend that up. And let's get a break line from another detail. We can just grab it, toss it right up there, trim, draw a drawing aid rectangle, and then trim everything that's outside of it. Then delete the drawing aid rectangle. Okay, detail's starting to come along here. Let's resize the fill of the concrete to fit with inside the concrete stem wall. Okay, send that layer to the back. Draw order, send to back. Okay, and then this is a vertical dowel that we're going to want to have embedded, let's say 12 inches into the grade beam. So I'll just draw a line, a drawing aid line 12 inches long. The bottom of that is 12 inches into the grade beam, so I just bring that hook down. This is called a hook. Bring the hook down 12 inches, right, and then extend that up to there. So what that dowel is doing, that hook bar, is it's attaching the stem wall to the grade beam, which is attached to the pile. And you see a curvy break line like that, it means that we're breaking into a rounded shape, like a pile, which is a cylinder. Just get rid of that. Okay, now the thickness of the concrete wall is 8 inches. What was the thickness? Here, I'm going to save, because sometimes my computer just turns off randomly. It's great. Great to have a professional tool that sometimes just turns off randomly and throws your work away. And now AutoCAD's asleep. I'm going to pause the recording till it wakes up. Okay, AutoCAD's awake again. Let's see if we can tell how thick the wood wall is. These two gray lines represent the 8-inch thick concrete wall. Maybe if I go over to here, I can see. Here, let's measure. There's the wood wall on top of the concrete wall. 3.5 inches. 3 9/16 is basically 3.5. So it's a 2x4 wall. The image in the detail I was already working on was a 2x6 wall. So I'm going to go into my toolbox. I'm going to grab a 2x4 wall. See there, 2x4 wall. Copy that. Go back over to my detail that I'm working on. Put that there. And now we get rid of this 2x6 wall and we put our 2x4 wall right here. Right on top of that. And notice I'm going to deliberately overlap it a little bit, okay, with the floor sheathing. Because now I can use the snapping function. I can move using M, grab onto that corner and move it up to the intersection of these two lines. Right there. And now it's perfectly set on top of the floor sheathing. Bring that down a little bit using the move command. Highlight this to make it a trimming edge and then TR for trim. Boom, gone. Okay. So, here, let's bring the soil down a little bit more than that. I like to randomize the edge of the soil just a little bit to show that the soil is not, like that line doesn't indicate anything, like the bottom of this is not an orderly thing. It's just the soil continues to go down to the center of the earth. That's what I mean by this. All right, so we've got here our wood wall sitting on top of the sheathing. One problem with this is that this is going to wick moisture up. This concrete stem wall will wick moisture up from the soil into the plywood, and the plywood then can mold and rot. So what I'm going to do is draw something called flashing here, like this. And thicken that a little bit using global width to make it visible. Okay, so that'll be flashing. It's sheet metal, bent sheet metal, like soda can material, bent and laid over the top of the concrete wall so that it's not directly in contact with the wood. Okay, I also need to grab some sill plate anchor bolts like this. put that into the wall. Boom, right there, centered in the sill plate. Let's check that I've drawn at least 7 inches of embedment. Yes, I offset that line just now by 7 inches, and I can see it's roughly to the bottom of the sill plate bolt. Okay. All right, so we've got our wall anchorage there. It's time to start labeling things. So I'll just go to another detail, grab one of these multi-liter bad boys. So this will be sheathing and edge nailing per plan. Right, and then I will point this is called a leader or an arrow. I'll point the leader at the edge nailing, and I will add another one pointed at the sheathing, being plywood or OSB sheathing. This landing, I like to have it be about as long as one of the letters is tall. Like that. It's about as long as the letters are tall. I've seen engineers drafters do this. I don't think that's enough of a landing. I've seen some fools do this where they have this kind of crap, and I just call that flying away. I say, why is the label for this flying away from the thing that we are indicating? So I draw it like that. I'll grab another leader right here, and we can see that's too short. Let's make that about as long as the letters are tall, which is, by the way, 1/8 of an inch on the printed page. Right, and these are going to be joists per plan. And I'm writing per plan to indicate, if you want to know the size and spacing of the joist, look at the foundation plan. Don't try to get them from this detail. Sometimes I don't draw these details fully to scale. I try to draw them to scale almost all the time, but I don't always. So I'm using this detail right now showing 14-inch deep joist, but let's say I copy this detail onto another project. I want to save some time. I just copy and paste the detail of the other project.
I don't know where I got the email.
But on the other project, maybe I'm using 11 7/8 deep joists, and I don't change these joist images. If a contractor looks at the drawings and uses his ruler to scale, he might find that these are 14 inches deep, or at least the image of the joist is 14 inches deep. And I don't want him to think that he should do that. He shouldn't scale the drawings. The contractor should look per plan over here, where the depth of the joist is literally called out. It's literally specified. Right there is 14. Also, let's say I'm talking to the client
What's your favorite shotgun?
or the architect who says, hey, can we use 11 7/8 deep joists? And I say, okay, yeah.
Okay.
I don't want to have to go back into my detail and have to resize the images of these joists. So I'm just saying joist per plan. Okay, and then this is going to be floor sheathing.
Can I play?
Floor sheathing and sill plank anchor bolts per plan. All right, all this stuff is per plan. And I'm kind of grouping these things together just so I'm not like writing floor sheathing per plan, sill plate anchor bolts per plan, sheathing per plan, edge nailing per plan. At some point the per plans get to be too much, so I just try to consolidate some of these. There's that. Okay, and then this is going to be foundation and GB per plan. Sorry, this should actually be stem wall and grade beam per plan. GB is grade beam. All right, stem wall, grade beam. This is exactly the kind of work that you can be learning to do and doing. Okay, and then let's specify those vertical
Can I
dowels.
do this
So
with
I'll
you
just call
guys?
these number 4 bars, number 4 vert at,
I cars
let's
rice.
see, 36 inches on center should do it. It's an engineering decision.
Dang it. Wait, I want to try.
All right, now I'm going to just recenter the detail a little bit. We're getting
Can
pretty
somebody
close to being
can you
done.
send
Oh,
me
flashing, I
what the
didn't
Frederick
specify the
was?
flashing. So,
I cars rice.
flashing
I cars rice.
along entire stem wall. Come on,
Yeah, that's me.
wake up, CAD.
Optimus Prime.
Okay, we can remove this.
Bro, these kids don't
Let's
use
see, the
headphones.
joists are just a bit in my way, so let's try repositioning that. Good. It's fine. Now let's recenter. I'm really
Yeah, let's do it. I'm down.
stickler about centering.
Bro, I
Hey,
always
hey,
get
shh.
top 10.
Hey, I'm recording
I
something.
always get top 10.
There we go. That's pretty close. Now let's save this. Okay, now we referred to stem wall and grade beam per plan, so it is important to make sure those things are on plan. So let's do that right now as we're referring to them. The grade beams, we're going to use what's called a foundation schedule. Remember the shear wall schedule gave information about the nature of the shear wall? Shear walls, and so now we will grab our foundation schedule, which is actually, here it's in company standards, schedules and notes. Footing schedule. Footing and foundation mean the same thing. Here, I'll grab this. Copy that. Paste it somewhere around here where I can easily find it. Footing schedule. There. Right. So just delete this placeholder. Put that over there. Okay, we'll call this G usually represents grade beams. Move the notes over there. So the grade beam in this case I think will be 2 inches wide, and it can have let's see, thickness, I'll just say 24 inches. Okay, so we'll call that type G1. Grade beam type G1. If I go back to schedules and notes, I can copy the symbol, the hexagon. There we go. Come back here. All right, and I'll just drop that right there. We'll call this G1. Okay, let's get that nice and centered. There's some art to this. Having sensitive eyes is a good thing. Okay, G1 and then a line over to it indicating this is the foundation we're talking about. And I wouldn't want to have this call out like all the way over here because it's flying away. It's like, why is it so far away? Right, so I would take it about this far. You'll form your own taste. And I put this at the center of the symbol. I aim this to where it's going to go. Grade beam, and then I trim this like that. It would be ugly to me and therefore disallowed in my company to have something like this. This just looks stupid where the line the line should go from the center of one object to the center of the other, in my opinion. Okay. And I will put in typical also. I don't want to put G1 all over the place because that's just a waste of time, and sometimes we change things. But I'll put it in a couple places because I don't want to. I want the contractor to be able to find that information easily. That right in the center. Boom. Right, and let's do one more. We can do it over here. It's fine. Okay, good. And now we need to, I'm just going to save again because I just really can't stand redoing work. Yeah, I'm going to go onto the plan view and I need a viewport in my foundation schedule. So viewporting, okay, this whole black space that I'm in is called model space. It's just a huge open void space where I could put anything I want in there. See, if I zoom out, you can see there's no limit to how much space I have. So all the things that are in my structural drawings are in model space. It doesn't even matter where exactly they are. I have given some framework here just to help me find things, but you can just have things scattered all over the place in model space. here is, and then we arrange things properly on sheets in paper space. I'll show you an example. So here's my footing schedule, right? There it is in model space. I'm going to go to the foundation plan here, where things need to be arranged correctly because they will be printed in this way. And I will create a viewport, which is a window into model space. There's a viewport. You can see right there, I can see model space. Okay, so I'm going to find my footing schedule, which is right there. Get it to the right size. Right, and then lock that viewport, and we're going to adjust the size of the viewport to fit the footing schedule. Okay, just like that. Pretty good. Right, and then I don't want this outline around the footing schedule to plot. Plot means print, so I'm going to set that on the def points layer so that it will not, the outline will not plot, but the footing schedule will. So now I've got a little problem. Where's my footing schedule go? Doesn't look like there's a whole lot of room for it. Maybe my symbols legend, does that need to move? Let's see. What should I do? Can the footing schedule go over here? Looks like it can. Okay, very good. It's a little awkward to have that all the way over there on the left, but so be it. I guess as an alternative, I could put the footing schedule down here. No, it doesn't quite fit. Even if I move these notes over to the right, that doesn't work. So we'll just leave the footing schedule over there. Save again because I'm a maniac. So we just viewported in the footing schedule. Notice that we put the viewport wherever we want, and it appears on the page. The viewer of this printed page will have no idea about model space or where anything is in model space. It doesn't matter. The model space is a tool we use. It's not the arrangement of things as will be on the page. So, now notice this. I indicated in my footing schedule that the grade beam G1 would be 2 feet wide, UNO, right, unless noted otherwise, and 24 inches thick. Okay, so I need to keep an eye on what will the contractor think width and thickness are. Okay, so let's do this. Let's grab one of these, put this here. We're going to call that thickness. That's what I mean by thickness per plan. Thickness per plan. Okay, I mean from the top of the grade beam to the bottom of the grade beam. I like things to be snapped very precisely. Okay, I move that to be centered on the dimension line, and then I'm going to draw a rectangle and then trim my soil fill out inside the rectangle like that so that it doesn't interfere with the letters. Okay, so thickness per plan, I mean from the top of the grade beam down to the bottom of the grade beam. And now what do I mean by width per plan? Let's grab this. Nope, I don't like the way that one looks. Let's see, is there one that I actually like? Here, this one looks better proportioned. Okay, this will be width per plan. Okay, we're going to use O-snap by pressing F3 to turn on snapping. Okay, and then let's try to get this dimension line somewhere where it will be visible. And then we can put this off to the side. I'll call it width. Right, and then the per plan part will have a space below it that's bigger than I want. So I'm going to create a separate object, a multi-text object per plan that I can then move over like this. So this goes width per plan, like that. So that clarifies to the contractor what I'm talking about. I should actually move this up onto the grade beam itself so the contractor doesn't think I'm referring to the pile diameter. So we'll have it like this, width per plan. Bingo. Okay, that's very specific. And then let's see, in my typical pile detail, pile and grade beam detail, I would hope that that stuff would be clear also. let's see, is the width of the grade beam indicated anywhere? No? No, okay. Here, grade beam thickness per plan. Right, so this is concerning because it's referring to the grade beam thickness in a different direction from the way that I referred to it up here. So this should be grade beam width per plan. Width, right? And I'm going to go back into my typical detail and modify that too, because that's actually not the right way to specify that. I mean, it's incorrect in my typical details. CAD keeps freezing. Maybe I need to restart my computer. Come on, CAD, wake up. There we go. All right. This is the typical detail file. It's got all the details that I've drawn and saved for future use. Width per plan is what we want. And while we're at it, let's move this over so it's put in the right spot. Okay. Go back to the drawings here. I'm still not totally sure I'm satisfied that width and depth have been defined well enough in this detail. I'm going to just save that away in my mind for future reference. I have some more detailing to do. Here, let's draw. Now we've got 3 on 3 0 drawn. Let's go on to this one. So let's see what is available on sheet 3.0. Looks like we've got here, right here. Here's a spot. We'll call this joist perpendicular to GB. Okay. And we'll get a screenshot of it so we can just have an idea of what this area looks like without having to constantly scroll back over there in CAD. Okay. It's a 24-inch wide grade beam. There's an 8-inch thick concrete stem wall on top, and then we've got our 14-inch tall I-joists butting up right on top of the stem wall. So I already am kind of seeing a tricky issue here, and I'll tell you about it. So let's get this detail, because what we're doing is going to look a lot like what we did. So we start here, right? So what we're showing here is our grade beam, our 8-inch thick stem wall. Those are all here, except in this case, the joists are going to go this way, right? Like that. And let me know, say out loud to yourself when you see the problem. And these go away. There are the joists. Do you see the problem yet? Little problem that the joist and the stem wall overlap in space. They intersect. That's not great, so it's not going to work in real life. So we have two options. One is to do what's called bolting a ledger to the face of the stem wall, like this, and then hang the joists off the ledger. There'd be a ledger on it, which is a piece of wood. Bolt a piece of wood to that side too. Then hang the joists on the stem wall. Option 2 would be to run the joists over the top. If we run the joists over the top, that's less concrete that has to be poured, so that's a good thing.
Can I join?
Let me think for a second.
Can I join?
I think I'll run the joists over the top. The reason for that is if I bolt a ledger to the face of the wall, it's going to look like this. We'll have our bolt, right, and then we mirror it like that, right, and then the bolt goes in here into the wall, okay, and secures the ledger to the face of the wall. Problem is that the contractor is going to use formwork to pour the concrete into for the stem wall. This bolt would have to be a hole. It would have to show a hole in the formwork. So the contractor's got to cut or drill a bunch of holes in the formwork, which is not awesome. So let's instead just drop the top of the wall down. The question is then, do I have to drop the top of the concrete stem wall down in the other detail that I just drew? Or will we have some concrete stem walls be higher than others? I don't know. Also, we'll want this to be set down 1.5 inches for a sill plate, for something for the joist to sit on and be attached to. Okay, let's do that. So there is this. Hey, can you see what my phone alarm is doing?
Fine, if you're going early, can you get something for me?
All right. So, we brought the stem wall down low. I need to go and get a, let's close concrete details, so I think I'm done with that. I need to go get an image of a 2x6 sill plate from my toolbox. Come on, kid, wake up. Right, let's go to the toolbox here. Right, and there's a 2x6. Copy it, bring it over here, paste it, and we can just set it down right there. And I want it to be centered. I really try to be careful to draw things centered, so I'm using the OSNAP function to center that sill plate. This goes away. Whoops. These sides of the stem wall now come down like this. Okay, so now you're seeing the sill plate. Bring the anchor bolt down here because it anchors things into concrete. So there's the anchor bolt. Okay. Like this. And then the joists are going to lap, so we need to draw the end of a joist and specify the lap distance. So that'll be the end of one of the joists. The end of the other joist will be over here, and it'll be dashed because you won't be able to see it. It'll be hidden behind the other joist, like this. All right, and now we need a break line. We can grab one from this detail over here. I actually like to have my break lines facing this way. So put our break line there. Extend like this. Boom, right, copy it, bring it over there. So this will be trimming, this will be extending, okay, flashing. We won't need flashing in this case because we'll just use a PT sill plate. This stuff all needs to come down. Like that. Okay, floor sheathing and sill plate anchor bolt. So in this case, the sill plate anchor bolt is down there. Oh, and also the vertical dowel is not extending all the way up into the wood portion. It stops down here in the concrete wall. So here I will do this. Sill plate anchor bolt for plan. We only need one of those leaders. Point that right there. Okay. Here. joist, 5.5 inches on PT, 2x6 sill. Okay, and notice that there were a few ways this text could be aligned. It's 3 lines of text. I like to get things as compact as possible. So like this to me, not as compact as possible, but pretty compact. This looks silly to me to have 1 line of text like that because it starts to dominate the placement of the detail within the detail square. I could make it 2 lines long. I would never do this where we have 1 line that's arbitrarily longer than the other line. So I would make them roughly equal, as close as I can get to equal, which would be that. That would be fine. Or I could go to 3 lines, and again, I don't do something like this. That looks really awkward where this line is long and this line down here is short. So I just play with this a little bit to see how close I can get them to equal. Like that, I think, is the closest. That looks good, and then I need we need some blocking in between the joists to keep them from rolling. So that'll be 14-inch, let's say 3.5 inch thick by 14 LVL blocking. If I can get AutoCAD to give me my toolbox. Okay. Go up here, we got 3.5 by 14. Copy. Bring it over here. Okay, so I'll start by, I want this to be really well aligned with the wall above. So I'll start by snapping this corner up to that corner, and then I'll move it and snap this corner down to this right there. That's very centered. You may notice that the blocking is now conflicting with the top of this anchor bolt. The contractor will have to notch out the rim blocking where the anchor bolt occurs, so the anchor bolt doesn't conflict with the rim. So we'll just say notch rim at AB. And now to make these 2 lines as equal as possible in length, it would look like that. Right, notch rim at AB, right there's fine. Okay, and then we'll specify that this stuff is 3.5 inch thick LSL or LVL rim blocking. Okay, things are getting just a little bit crowded. So what should I do? Maybe I can stretch this out to be 2 lines long, right, and scoot this in. I like to have the text objects aligned just to look neat. So I'll just draw a drawing guide here, bring this out. Right, we can bring this in, bring this in. And then this one, I'm not sure there's any hope for this, so I bring it in. Yeah, that works. That's fine. Yikes, I lost my leader head. There we go. There. So now they're all aligned. Let's see, we got rim blocking. See, there's no shear load path from the sill plate into the rim blocking. So first, we do need a shear load path from the floor sheathing into the rim. So we'll do this. That can be nailing the floor sheathing to the rim blocking. And then we need shear wall anchorage into the rim blocking, so we can specify some SDS screws for that. Perhaps 5.5 or 6 inch long screws should do. Here or here. Get both of them. And let's see. Does that work? Yes. And I'll delete the other one. So the key is I want the threads to be fully embedded in the supporting lumber, which is the rim. We're trying to transfer loads into the rim. So I want the threads to go all the way into this rim blocking. Let's bring this down, right, and indicate that this is SDS per plan. I'll have to stretch that out to have some room. There's this. Bring that up. Getting a little crowded up at the top. Maybe there's some more room down at the bottom I can eke out. me just bring that down just a little bit. There we go. Okay. Let's get this up here. There. Okay. Shear load path from the shear wall sheathing into the edge nailing, into the sill plate, into the SDS screw, through the screw, into the rim blocking, and now what attaches the rim blocking to the sill plate down here? I could use A35 clips, or I could use LTP4 clips. Let's try LTP4s, which look like that face on, and they look like that from the side. Okay, and we'll make the LTP4, we'll have it go on this side, and here's a little problem. We just move this out of the way so we can see for a minute. The LTP4 is able to go nail into the sill plate, but here the nail is not getting into the rim. So what that means to me is I need to offset this whole thing, the rim blocking and the wall above. I need to offset them to the right, just like this, so that they have a common surface with the side of the sill plate, so that we can attach the sill plate. Come on, AutoCAD, wake up. There we go. We can attach the side of the sill plate to the, whoops, come on, here, like this. There. Now the LTP4 lies along the sill plate and the side of the rim blocking. Okay, what else changes here? This leader has to point at the side of the rim blocking. I like to point at the sides of things, the edges of things, rather than like just randomly into the thing. Notice this arrow is not pointed at anything directly. So the edge of the rim is right there. Okay, we need to move this SDS back over to where it was. Let's see. Notch rim at AB. Still true. Want that to align with the other text. Put that there. And now our sill plate, our LTP4 call out is having some difficulty. So where will we put it is the question. So let's move this over here. Things are getting crowded. So I'm going to do this. Notch rim at anchor bolt. Just like that. Put that there, and then this now will become LTP4 at 36 inches on center unless noted otherwise. Right there. All right. Looking good. Got the stem wall, grade beam, piles, floor joists, wood wall above. Let's make sure they're actually first. Okay, this is going to be detail 1 on S3.0. So let's go here. Call this detail 1 on S3.0, and let's even make sure there is a wood wall there. I see the concrete stem wall. If I go to the next level up, I'll use one of my guide lines because sometimes it's tough to tell exactly where you were looking. Looking right there. Now I follow this line over to the next level up. I don't see a wood wall there. So what? Let's double check the architectural sections through here, because I just see floor area. I don't see any like doors or windows, and I just want to make sure I understand what is happening at this level of the building. Here, okay. So let's go to the plan view. Here we go. Here's a section that's cutting 1A11, cut right through that part of the building that I'm working on right now, right through there. Okay, so we go over to 1 on A11, and we see, there aren't even floor joists down here. Okay, so here I am detailing this thing as if there are floor joists right here on both sides of the grade beam, but in that part of the building, that's not even true. There aren't even floor joists over there. Whatever, this is the way work goes sometimes. So okay, I need to go back to my plan. Whoops, go back to the right file first. Go back to the plan, and then I delete these. These joists aren't even there. Goodbye. 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 There. All right. That detail I just drew, is it useful anywhere? What about here? Nope, there are no floor joists up there. It was 111, 1 on A11 where we're looking at. Yeah, no floor joist right there either. So good, I'm glad I caught this. I don't want the architect to catch me doing something silly, making a silly mistake. And then, all right. So detail 1 on 3.0 then is not going to have floor joists in it. I like that detail. I think I did a good job of thinking it out and drawing it. It might come up either in the future on this project or on another project. So I'm going to make a copy, set that copy aside, and now just double check the section, which shows just some kind of post and beam stuff sitting on the wall. All right, it's this one, just a post and beams under here. So let's go back to my plan. We're not going to have joists or floor sheathing. Genius. Okay, we're not going to have a sill plate. So basically everything about this detail is wrong. We're not going to have that, we're not going to have that, we're not going to have this, no. No. That, yes, and then we will have is a post. Oh boy, and let's say that that post is a 4x6 post. It will need to sit on a 4x6 post base. If I can get to my toolbox, if AutoCAD will let me, then I can grab that post base image and copy and paste it. There we go. ABA post base should work just fine. Just like that. Copy and paste. Jam that right over there, pretty darn close to center. It's not centered, it should be so close that I can't tell. All right, and then we draw the edges of a post coming up like this. Just like that, boom. Okay, 4x6 post. I need to actually design the beam so I know how big the beam will be. Go over to my guide here, and it says that I was right there. So I got to draw this beam on plan. So let's draw it. Just like that. And I can see the outline of the posts. The architect has done a pretty good job of thinking this building out. 5.5 by 5.5. So he's seeing this as these are 6x6 posts, which should be just fine. That should be more than enough capacity. There's my beam label. Question mark means I haven't designed it yet. Looks like we're going to have a similar case over in this area. I'll have to look around for other cases that are like that. Maybe this one too. Let's go back and look at the architectural section. So there's the beam. Oops. There's the beam. God, everything's so big. Okay. And then there's a beam and post situation at the other grade beam also. I don't know why he offset the beam and post off to the edge of the grade beam. I don't know. So 6x6. So let's draw those in. Do they have to be 6x6? I don't think so. So I'm just going to use 4x6. I'm pretty darn confident that a 4x6 post will be sufficient. I'll put those in, and then I'll finish the detail, and then we'll call this a wrap. Come on, CAD, let's go. Thank you. 4x6. Actually, I've already got 4x6s on my plan somewhere, so I can copy them from there. Never mind. Let's go back here. Get this 4x6. just stick that right there. Pretty darn close. There. Okay, and then 4x6, we got a 4x6 over here. Any others? Here. Right, and then we have one in the wall like that. Right, and then we need a post call out to indicate that that's a 4x6. There's a post call out with a 4x6. And just like this, 4x6. And I'll write tip, so I don't have to indicate, I don't want to specify the size of every single 4x6 out here. And I don't like how the text is crossing the line of the foundation, so I may tip that up a little bit. Looks like it still doesn't quite work. I can set a background mask on this text. Use background mask 1.0, use drawing background color, like that. And now the text overrides the foundation dashed line. Let's save this. All right, back to detail 130. So I got my post. Oh, regarding the beam, I still don't have the size of that. I'm going to guess, let's see what the span is. The span means how far between supports. Span between these posts is 6 feet. I'll bet that a 6x6 beam will work. So I'll grab the image of a 6x6 right here, copy it, go back to detail 1 on 3.0. Let's wrap this detail up. Paste that in. First, let's move this stuff out of the way. All right. Okay, and remember, we only need the joist to be 18 inches above the soil. Let's see what the architectural section shows. Because it's a sloping site, so there's some special business going on here. I'm going to make sure the scale is correct, so that should be 8'1". I measure 8'1". I'm going to make sure my software has the scale correctly. Yeah, I measured it as 8'1" also. So in this guy's drawing, he's got the bottom of the joist being 7'10" above the top of the grade beam. I'm not going to draw 7 feet 10 in my drawing here because that's just a waste of space. So I will use a break line here to indicate, hey, there's some height of this post that I'm not showing. Just like that. This. Clean that up. All right, and we can bring this down a little bit. Bring that back in. Oopsie doodle, that wasn't what I wanted. Okay. Come on now. Got extra lines here. I don't like having extra overlapping lines. Call me perfectionist, but it just seems weird to have more than one line occupying the same space in the drawing. Oh snap. Nope. Oh, that was oh snap gone wild. I want it to snap to the corner and then not to anything else. There. Alright, and then the joists frame in over the top. So what I can do is I can just grab those. Okay. Getting kind of tired here. Okay, so the bottoms of the joists go like that. I feel like there's more to this detail that I'm going to need to show to make this clear. Okay, and then we need all of our joist stuff. See, I knew this would come in handy. I'll just grab this joist business, copy it. Just like that. Very good. Yikes, not enough room. What can we do here? Let's trim up here. Super tight. Okay, let's bring this. It'll work. We'll get it. It always works out in the end. That. Okay, lap joist. Yes. This is going to be beam per plan. Beam per plan. That's some other stuff I have to do. Wrap this up. Okay. Alright, lap joist, yes. LVL rim, yeah, we'll use that. LTP 4s, still use those. Need to go grab that LTP 4. Come on, CAD, give me my mouse cursor back. Frozen, 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 frozen. This is a problem sometimes with AutoCAD where it just lags for no apparent reason. Come on, man. Alright. Bring the LTP4 back. Perfect. This down. Sheathing and edge nailing per plan. Do that. Okay. SDS per plan can come over here. Like that. Okay, what's going on? Our floor sheathing and sill per plan, floor sheathing and sill per plan. Oops, nope, just one of you goes. There we go. Right, and then this is SDS per plan, that goes away. See how it's coming? It always works out. Make this 2 lines tall. Right, there we go. This, bring this down. There. Pretty tight. We also need a post cap right here on top of this cripple post. So we'll say these are called short posts, they're called cripple posts. So cripple post per plan. Everything's per plan. La 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 la. Okay, and then this is going to be ABA post base with 1/2 inch diameter, hot dip galvanized all thread with 4-inch embedment. Come on. That's ugly. Okay. Beam per plan. We need a post cap. I'll go to the toolbox, get a post cap right here. Here. It sits like that. Connects the top of the post to the beam. Push this up. And this can be PCZ post cap. Which is in the Simpson catalog. Okay. There we go. All right. It's kind of dense, but it's all right. It's got everything we need in it, I think. Full load path. I'm going to save that detail and I'm going to quit for now.